Now refraction through the prism. Look at the figure in which we have shown the path of the ray incident. The ray is incident at an angle I. I is the incident angle. It is refracted at the first face of the prism at an angle R1. Then it is incident on the face AC at an angle R2, and it emerges through the prism at an angle E. E is the angle of emergence. Now here this I is the incident angle, R1 is a angle of refraction, R2 is a angle of refraction at the other face AC, and E is the angle of emergence. Now you look at the figure carefully, figure only. Okay, look at the figure very carefully, how the ray is formed, how the ray is refracted and emerges from the prism. Okay, look at full geometry of the figure, complete geometry, try to understand. Here we can apply the rules of geometry and will derive the expression. Here in quadrilateral AQNR, A, Q and R. Okay, angle A plus Q and R, opposite angles A and Q and R, is having the value, sum of these two is 180 degree. And if you look at the triangle Q and R, then in that triangle the sum of all angles R1, R2 and Q and R is 180. Here with these two expressions, what we got, equation 1 and 2 are having same right hand side, that is 180. So you can compare. Left hand side is 180 for expression 1 and 2, you can compare, and with the comparison what you will get, if left hand side is same, so the right hand side. So with that comparison, A is equal to R1 plus R2. Keep this expression in your mind, this is quite useful. Now here delta is the exterior angle for the triangle MQR. For the triangle MQR, delta is the exterior angle. Exterior angle is sum of opposite angles. What are those opposite angles? I minus R1 and E minus R2. Keep R1 on R2 on one bracket, and you know the R1 plus R2 is A, so we come to a nice expression. Delta is equal to I plus E minus A. Therefore A plus delta is equal to I plus delta. This is a useful expression, may be asked in exam. Here with this expression, you know the angle of deviation, that is the angle between the incident ray and emergent ray. Angle of incidence is what? If you look at the figure, then in figure it is explicitly shown. Delta is the angle between incident direction and emergent ray. Okay, if you plot this angle of deviation versus incident angle, then you will find this shape of the plot. As you increase the angle of incidence, deviation reduces at one particular value of incident angle, which is exactly equal to emergent angle of emergence, and for that point you will get a minimum deviation. Delta is having minimum value. If I is equal to IE, then delta is equal to dm. And one more interesting fact here we come across, that is R1 is equal to R2. If R1 is equal to R2, then your R1 is equal to A by 2. Now substituting I is equal to A, one more substitution. If angle of emergence is exactly equal to angle of incidence, then in that case you will have a minimum deviation. that is dm. We have a specific notation for minimum deviation angle, that is dm. So put I is equal to E is equal to I and delta is equal to dm. You will come to this expression, I is equal to A plus delta m by 2. Okay, now what we are going to do, we are going to apply the Snell's law. Snell's law, you know, n1 sin theta 1, that is n2 sin theta 2. Here we are applying the Snell's law at face AB of the prism. Here, medium through which the ray incident, it is air, normally having refracting index 1. Okay, and it is refracted in the prism medium, so it is having refractive index n. Substituting I is equal to A plus delta m by 2 from the earlier equation, R1 is equal to A by 2 from the earlier equation. If we substitute I, N1, N2 and R1, then we'll come to this expression. Okay, and if you make N as a subject, this is a quite interesting and important expression for refractive index of prism in terms of minimum deviation angle, prism angle. A, I want to mention that A is nothing but prism angle. For normal prism it is around 60 degree. ज़्यादातर ये 60 डिग्री होता है.